Everyone please open your books and write the lesson intention that is on the board at the very top of your page. Once you have written that into your books, I would like for you to get your last assessment task out and have that waiting on top of your desk. Okay, so our lesson intention for today is to construct a correctly drawn scientific graph based on success criteria. To do this, we need to understand what is meant by the term success criteria. Success criteria is the minimum required to obtain full marks for a task. You are provided with success criteria for every assessment you complete at school, and you need to learn how to use it to get full marks. In the assessment task that you have out on your desk right now, you had to construct a graph, and there was set success criteria for that graph. If you fulfilled all of the criteria, then you would have got full marks for that graph. We are going to have a look at an example of success criteria and make our own in a minute. However, I would like for you to write what is in the yellow box in your books right now. Here is an example of success criteria. I have taken this directly from the assessment task that you have in front of you. The criteria lists that students will be assessed on their ability to identify the purpose of the investigation and the question or hypothesis to be tested, describe a logical procedure for undertaking a simple or controlled experiment, identify variables to be held constant if reliable first-hand data is to be collected, select appropriate equipment and assess risks, present observation and measurements clearly to show trends and relationships, discuss the results using cause and effect relationships and explain how the procedure and results could have been improved, and state a valid conclusion identifying data which supports or discounts the question or hypothesis. As you can see, there are a set of dot points that explain exactly what you need to include to succeed in the assessment task. This is one example of success criteria, and this is how it will be set out in every assessment task that you do throughout your schooling. You need to understand how to use this criteria as a checklist and slowly check off each dot point as you assess your own work before you submit it to the teacher for marking. Now we are going to have a look at two examples of graphs for the assignment that you just completed. One of these graphs would not have obtained full marks, and the other would have received full marks. I want you to silently decide which one you think is incorrect. I will be using the paddle pop stick method to decide who I will ask for this answer. Jackson, which graph do you think is drawn correctly? Yes, the one on the right is correct, and the one on the left is incorrect. Let's have a look at why. This graph has no axes labels on its horizontal x-axis or its vertical y-axis, giving no description of what its axes are representing. The title is also not descriptive enough. It simply says freezing point. Freezing point of what? Looking at this graph right now, I have absolutely no idea what it is about or what it is trying to represent. These bars only come halfway down the graph, using only half of the space that was provided. The scale is incorrect, and therefore the graph is much smaller than it needs to be. It has not used the space very well at all. You can also see that these columns are coming downwards. This is not a good way to represent the data because it makes it a lot harder to compare each column. You need to be able to easily compare each data point that has been plotted on the graph. Overall, this graph does not provide a clear representation of the data, and it would not have obtained full marks in the assessment task. This graph has been drawn correctly. It has a descriptive title that explains what the graph is all about. It has axes labels with the correct units. As you can see here, they've written degrees Celsius for freezing point and grams for the amount of salt added. The scale allows for the data to be spread out over the graph area. This effectively represents the data so that it is clear. And because the data is classified as continuous data, that is, it is a measurement, the use of a line graph rather than a column graph is much more effective. In science, line graphs are much more commonly used than column graphs. So much so that I would like for you all to use line graphs unless I specify otherwise. Alright, based on what I have just said about those two examples, I would like for you to put your hands up and contribute some ideas about what typical graph success criteria would be. You don't need to write this into your books just yet. Okay, let's quickly review the criteria that we brainstormed all together. Typical success criteria for a scientific graph needs to have a descriptive title. The x-axis should display the independent variable, which is what we are changing, and the y-axis should display the dependent variable, which is what we are measuring. The axes should be clearly labelled, including units where applicable. Scales should be selected, which allow the range of data displayed to extend over most of the available grid. The axes do not need to start from zero. There should be accurately plotted data points. And a key should be given if there is more than one line shown on a graph, so that each line is easily identified. Does anybody have any questions about that criteria? Now that we have decided what makes a good scientific graph, I would like for you all to copy what is written in this yellow box into your notes. In a moment, I am going to hand out graph paper. You need to use this graph paper and the data below to create a correctly drawn scientific graph that fulfills all the criteria we have discussed today. You can do this with the criteria list in front of you. However, after you complete this example, you are then going to complete another graph of a different data set under exam conditions. So this is a practice go. Please put up your hand if you have a question while you are completing this activity. I want everyone to understand the success criteria and how to use it before we attempt the next activity. Once you finish your graph and the person sitting next to you has also finished, I would like for you to swap your work and mark each other's graph. You can speak while completing this activity. However, I would like for the noise to stay very low, and all of your conversations need to be about the graph. If you cannot be trusted to speak quietly about the activity, we will complete this activity in silence. You now need to put your books and the graph paper that you just completed on the ground next to your desk. Leave a pencil and a rubber on your desk and nothing else. Everyone needs to be completely silent from here onwards. I am going to hand out one piece of graph paper to each student, and under test conditions you are to use the data below and the graph paper provided to create a scientific graph based on the success criteria that we have discussed. Once you finish, sit silently whilst other students finish the task. Do not speak until I have collected all student work. Please put your hand up if you would like another piece of graph paper at any stage, or if you have a question about what you see on the board. You may begin.